Hey guys, today we're going to be doing an LS430 2000-2003 going into an IS200 with a manual gearbox. So, let's get into it. Right, so as I said, this is an LS430 2000-2003 going into an IS200 using a manual gearbox. So as you can see, this is an adapted harness. What I mean by that is you can see it's an original harness that we've taken, cleaned, stripped everything off, repaired what needs repairing, and obviously added what needs adding in. So first thing we're going to do is let's cut to some photos of that process so you can see exactly what goes into making this harness. See you in a second. Right, so there you go. Yeah, you can see we strip everything down, clean everything, remove everything, repair what needs repairing, as you can see with the coil there. And then obviously we put it all together, add in the stuff that needs to be added in. So what we're going to be doing today is, first of all, as per usual, we're going to go through the layout of the harness. So we're going to show you where everything goes, where it plugs in, and any little extra bits and bobs that you might need to know. Once you've done that, we're going to then start into the testing. So that's going to be made up of two parts, one with the ignition on and one with the engine running. So that is the entire video layout that we're going to be doing today. So let's start with the layout of the harness and starting right here at the ECU box. Okay, right, so there is your 3UZ ECU. It is what I call the wedge-shaped ECU. It's the same as an IS300 if you're in Europe or America from a 2002 to 2005 IS300. Right, so as you can see, this is actually a half cut from an IS200. Now the IS200s had the rectangular shaped ECU, so obviously they're not accommodating for this little lip that you have over here. So you do have two options when it comes to that. Either you can source an IS300 ECU box designed for this wedge shaped ECU and that'll drop straight in, clamp up, no problem at all. If you can't get your hands on that, then what you can do is you can remove the 4 bolts that are over here. Hopefully you can see them. There's 1, 2, 3, 4. You can basically pull this out. So if you do have these little latches on, you do need to take those off as well. But you can pull that out, which is the entire PCB board, leaving you with just the bottom case. And feel free to take an angle grinder and you can grind this lip off. And once that lip is grinded off, these actually slot directly in there. So those are your two options when it comes to that. Okay, now then, connector time. So on here, we have our 3 connectors, which are mainly for the actual engine harness itself. We have our 2 connectors here, which are basically body plugs. There are some wires that go into the engine harness, obviously, as well, which is obviously why we need to make this patch harness section over here. But those are your 5 ECU connectors. They are all different, so you can't plug them in the wrong way, so never stress about that. But obviously the way you've cable tied the harness together obviously dictates sort of where they go in. If it looks weird, then it's probably in the wrong place. Okay. These two obviously go to our patch resin section. Okay, so these plug into the two connectors that are left behind in your IS200 when you've removed your 1G-FE engine. Right, then we have our stop relay or brake relay, STP relay, whatever you want to call it, and that is this one over here. Now again, the reason we do that is because on the IS200s, they had a weird situation where the manuals never had cruise control. So they were never fitted with a 4-wire brake switch, which is what the 3UZ would have been fitted with, which is what the IS200 Auto would have been fitted with, which is what the IS300 is fitted with. So in order to replicate that, we do fit this relay in. Now, even if your IS200 was originally an auto, we do still fit the relay in because we don't want you to ever be limited if you wanted to sell the harness onto somebody else to say, oh, you can only buy this harness if you have an IS200 Auto, otherwise it won't work. So again, that's why I fit the relay, so you could sell this harness onto anyone with an IS200 further down the line, so we don't want to limit you in that regard. Then we have our little tacho converter device over there. So basically that is converting the 4-cylinder signal. So obviously the ECU is giving out a 4-cylinder signal for the UZ series, and it's taking that 4-cylinder and we're adjusting the signal to be a 6-cylinder signal on the other side. Okay, these are adjustable. So again, if you are sitting in the car, again, I'm trying to do it with an idea of what your eye level would be, but it is adjustable, so you can fine tweak it, because obviously you can plug in an OBD2 machine, read live data, which of course one is engine RPM, and you can fine tune that. Right, moving down to there, and then we have 3 body plugs. So we've got a gray plug over there, black plug over there, and a blue plug over there. You see the bottom matches the color there, okay? So that is perfectly fine. You can't get in the wrong place, just match the colors up. But even so, they are completely different keyed connectors, so you could literally never plug them into the wrong place. Super easy. Right, and this is a junction connector, so this just gets tucked down the side over here when you put the harness in. Okay, so what I'm going to do now is, obviously it's a bit of a mess when it's in the half cut over here, so I'm going to cut to a photo of now what it looks like when everything is in and tucked away. Fantastic. So now you can see exactly what it looks like when you actually have it in the vehicle. Okay. Moving along from there, we then have the grommet, which goes in there, as you've probably seen from the earlier picture. Harness then moves along and it comes over to the side of the engine over here. Now, before I go any further, this is called the left-hand side of the engine, and that is the right-hand side of the engine. It can also be referred to as bank 1 and bank 2. A nice easy way to remember that is this is cylinder 1 here, and that is cylinder 2 over there. Okay. So odd numbers on the left bank, so we've got 1, 3, 5, and 7. Even numbers on the right bank, we've got 2, 4, 6, and 8 on that side over there. So just going to clear that up at the beginning so you know exactly what it is. And so what you can see is we're always looking from the driver's perspective, okay, from inside the vehicle. So looking at the back of the engine, that's how you determine your left and your right, okay. Right, so getting back to over here, we have a little piece of plastic that's bolted down here and here, okay. Nice and simple. And from here, you'll see a little breakout section over there, which goes to injector 1 and coil 1 over there. So that's fantastic. Moving along there, breakout section at the front here. And the first one it's going to go to is your oil control valve for your left bank. So this is obviously the VVT-i solenoid. As you can see, it's only controlling the inlet cam, not the exhaust cam. Okay, so your VVT-i on these engines is on inlet cam only, not on the exhaust cam. Okay. Coming further down, we have another breakout over here, which is going to go to our TPS connector. So if you watch our other videos, you'll know that this is a 5-speed because you've got the 4-pin TPS connector there. And you've got the 2-pin throttle motor connector over there. Okay. Again, 6-speed models have a 6-pin plug on that side. All right. Moving further along there, we then have a breakout over there, which goes off to our front cam sensor. So remember, on the UZ VVT-i models, you have 3 cam sensors. You have one at the front here, which is measuring a single tooth, which is moving around on a stationary cam lobe that goes on there. Not lobe, wheel, whatever you want to call it. Anyway, gear, I think cam gear. So that's measuring a single tooth on the cam gear on this side. And in conjunction with the crank sensor, obviously that can tell engine position for spark and fueling. Okay. The other 2 cam sensors, which are only measuring the inlet cams on the left and the right, obviously they're to measure the cams to make sure that if the ECU commands a certain degree of advance or retard on the cam, that is actually being done on the engine. So that's how you can get an error code to say there's something wrong with your oil control valve. Because if it says I want X degrees of advance or retard, it can measure it there and it can go, right, it's just not happening. I'm not getting that information. It'll go, right, there's something wrong with the oil control valve. Okay. Right, moving down from there, we then have clamps here and here. So again, these are not the original clamps. These are ones that just I had lying around, and they're easier to take the wire out of because again, I do it all the time. Moving down from there, once you get past that, it's going to break up into 3 sections. So you can see the 3 wires over there. So first of all, we have our AC plug. Okay. Now remember, please note that the AC pump on an LS430 2000 to 2003, okay, although it has this tri-plug on it, which is obviously a common Toyota AC plug, it also has a solenoid on the back of it, okay. That solenoid is not controlled via the engine ECU, it's controlled via climate control ECU, which is obviously impossible to integrate into an IS200 without an extensive amount of interior wiring. So the best thing that you can do is get yourself a GS430 2000 to 2005 or an SC430 2000 to 2005, 2001 to 2005. And I have a sneaking suspicion even the 2006, 2010 might have it, but don't quote me on that. Anyway, the other option is a 3UZ-FE VVT-i, so that's an LS400 98 to 2000. That AC pump will bolt straight up and plug directly in over there. So any one of those pumps is absolutely fine. You literally just can't use the LS430 2000 2003 one because of that solenoid on the back, which we can't control via the engine ECU. And obviously we can't make a plug and play one if it requires extensive wiring on the inside of the vehicle. Okay. The next section to pop out over here is going to again come through here. You can see the hole over there. Remember, your AC pump will be here if you're keeping it. And then it basically goes down here. You can actually see both of them go down there. Now then, this is an LS430 engine, so it has this oil filter housing that brings it forward. You can't use these on the IS200 300 Altezza swaps because it's going to hit the sway bar, okay? You need to have an oil filter housing from anything that came with a front sump. So you can see this has got like the mid sump, okay? From the LS430. Now, these sumps are obviously hell of a useful for IS250 or 350 swaps because they use the same type of mid. Well, it's not that they use the same mid sump, it's that the IS250 has the same subframe as the GS430 third generation, and they used a mid sump like that. So you can bolt any 3UZ with this sump from an LS430 or a GS430 from 2005 to 2007. And if you use GS430 engine mounts from a 2005 to 2007, you can actually drop this engine directly into an IS250. No modifications required. It just slots straight in. Okay, so these sumps are good for that, not good for the IS200 300 swaps. Okay, so you need to get your hands on a rear-facing oil filter housing, or just going rearwards. Okay, those you can get from anything that came with a front sump. So that's going to be GS430 2000 to 2005, SC430 2001, all the way to 2010. Okay, all the SCs came with a front sump. LS400 98 to 2000, that is a 3UZ VVT-i. Now, the reason I would say try and get those ones is because basically they're a straight bolt on. Okay, do bear in mind that you can put a 3UZ non-VVT-i front sump on, which is pretty much most of the ones you'll find in Europe. So they were basically LS400s from 89 all the way to 97. The only problem is the hole size is different. So you need to modify a non-VVT-i sump to fit onto a VVT-i engine. If I remember correctly, it might be the other way around. I think these are smaller holes than that one, so the other one's actually bigger. Anyway, the hole size is different on the bolts that go from the sump to the block, okay? So just make sure if you do get a non-VVT-i one that you are aware of that it may require modification. I can't, off the top of my head, remember which way around requires modification. Okay. Right, okay, so now that I've explained all that in great detail, the reason I am explaining that is because you can see here that your oil pressure switch is on the front of the engine on the LS430, but on the rear oil filter housing, it's going to be actually sticking out facing backwards like that. So that's the reason we split the oil pressure switch at the top here, because you can take it through here, bring it out here, and plug it into the switch over there. And meanwhile, have your crank sensor, which again is one of these two wires, pop down through there and plug directly into there. Okay, so everything down here is basically oil pressure switch, which in your case is going to be facing backwards over there, crank sensor, AC pump, cam sensor at the front. So that's this whole front section all done now. Right, so let's move on. So again, plastic goes around the corner over there. We have a small section where it's just sort of taped up over here. And then we have the next piece of black plastic holding everything together. So that bolts in there and there. Nice and easy to see, just M10 millimeter, not M10, M6 bolts, 10 millimeter socket to tighten them up. Okay. Out of this plastic, we have three sections that pop out to go to connections. So the first one over here goes to injector 3, coil 3, and obviously the cam sensor for the left bank. Okay, so this is commonly referred to as VVL, VVT for left bank or variable valve left bank measurement, whatever you want to call it. But this is a cam sensor for the left bank. And it's 3 lobes on the inside here that it is actually measuring. And the reason it has 3 lobes is because obviously it needs to do degrees, so it needs more than 1 point. Okay. Moving along to over here, we then have the next breakout, which is going to be in injector 5 and coil 5. We then have the plug for our noise filter, which goes directly on the top over there. If you don't get it to focus. So it can plug directly in over there. So remember, basically what you're plugging it into, that gray thing that bolts to your cylinder here, inlet manifold there, it's basically just a capacitor. It's designed to absorb any electrical pulses or noise generated by the coils and the injectors as they pulse. Okay, so again, this helps to prevent noise getting into your cam sensors and your crank sensors. Anything with a shielded cable, it's basically there to help prevent it. Does also help to prevent sort of humming on the radio. Usually, sometimes your speakers can actually pick up the pulses of the injectors and the coils firing, so you might get a slight hiss through your speakers. That also helps with that over there. So that just plugs into the capacitor, which bolts onto there. So the other side of the capacitor is being earthed through your inlet manifold. That plugs into there. This is providing the positive. So you can see it's a red wire, which matches the red color on all of the coils. So you can see there, they all have a red wire on them there. All right, so that's that section over there. Then the last section is going to come out and it's going to go to injector 7 and coil 7. Okay, super nice and simple, nothing too hard there. You can basically see they go boom, boom, boom. So it's cylinder 3, cylinder 5, cylinder 7. Really simple, nothing major there at all. Okay. Now, moving around here, you'll see there's a little section where it is taped up as well to move into our next piece of plastic that's holding everything together. While I'm here, just remember, guys, these are fuel pulsation dampers. They are not fuel pressure regulators. So screwing the screw, which you can see in the top of this one over here, does nothing more than actually just break it, okay? So again, these run a deadhead system. So for the IS200, 300 Altezza swaps, you just basically leave your existing pump in. I would advise if your car is about 10 years old or 20 years old and you've never changed the fuel pump, while you're doing the swap, you may as well change the fuel pump just to make sure that everything is hunky-dory. But basically, you connect your fuel line that comes up from here straight onto your fuel rail over there, and you do nothing else. The fuel regulation is done inside the tank on an IS200. So do bear in mind, if you have fitted a turbo or a supercharging IS200 and you fitted a fuel pressure regulator, okay, and that whole system is set up, okay, you can leave that in place. It's absolutely fine, but you want to make sure that you're setting your fuel pressure between 3.5 and 4 bar, okay. What you also want to do with this particular setup here is you want to maintain a consistent fuel pressure. So what I mean by that, normally on your fuel pressure regulator, you would have had a vacuum pipe going from your inlet manifold to one port on your fuel pressure regulator. If that is the case, just remove that vacuum pipe and don't attach to the inlet manifold. That will mean that the fuel pressure regulator will just maintain a constant fuel pressure, okay? We found good results at 4 bar, not sure what that is in PSI, but 4 bar gives you good results, but absolute minimum needs to be 3.5 bar. So once the engine is running, just set the fuel pressure regulator at 3.5 bar or 4 bar and run with it and see what you like. You can adjust it maybe 3.8, 3.7 or whatever. All right, so that's the fuel side taken care of. So let's move back over to our piece of plastic over here. Just gonna move this out of the way. Right, so again, this piece of plastic at the back just has 2 mounting points. You've got that bolt over there, and you've got that bolt over there, okay? Nice and simple, just 2 bolts. Again, they all use a 10mm socket, so they're all M6 bolts that these are gonna be going through anything sort of holding the plastic on over there. All right, now in this particular case, our first breakout is down at the bottom over here, and we have 3 things that pop out over here. Number 1 is our earthing point for the harness. So again, M6 bolt, 10mm socket, tighten that down, okay? On the 3UZ, you should only have this bolt in here. You will not have this bolt in here, so don't freak out. I have this on here because I put 1UZ VVT-i engine harnesses as well as 3UZ engine harnesses on this engine. So I have the 1UZ VVT-i earthing point, and I have the 3UZ earthing point on there as well. So you are only gonna have this one. So don't freak out if you don't see this bolt or this bolt. I've added those in. You should only have that one, Okay. Also, while you're here, aluminium loves to rust, forms a little powdery coating. So before you bolt this up, grab yourself a piece of emery cloth and quickly give it a scrape down and then bolt this down onto there. So you get a really good, decent earth on this engine harness. Okay. Next up, going down through there, popping out through there, and hopefully you can see it over there. There is your O2 sensor connector. I want to see if I can see it from underneath. There's my O2 sensor, and I've actually tucked it away by the block drain over there, and you can see the connector over there. Now, very important, there is a metal plate that bolts to the cylinder block, okay? And this connector goes behind that plate. So that plate is the barrier between the exhaust and that connector. Please, please, please do not leave that plate off. If you do leave that plate off, there is a 90% chance that that connector is going to end up falling on the exhaust. It's going to melt, and then obviously it's not going to work, and you have to replace both connectors on the Lambda sensor and on the harness as well. Okay. And not to mention the plus B circuit that supplies the ECU is also connected to the Lambda sensors. So if you melt it and there's an earth and a 12 volts and they short, your whole ECU is going to shut down base and your car is going to basically come to a complete halt. Okay. So please, please, please put that plate in to keep that connector secure away from the exhaust. Okay. Next up is our gearbox harness. So obviously this was originally an auto. There was a whole automatic gearbox harness that came out here. As you can see from the photos earlier, we've stripped all of that out. We've removed every single wire for the automatic gearbox. And now this is where we start adding in our own section of wiring. So again, you saw me building these in the earlier photos, but this is the gearbox section. So again, everything is labeled for you guys, so you don't have to worry about doing that. Now, obviously, the reason we put a connector on here is that you guys do change your mind. Obviously, we've got experience of that. And what basically happens is we put it on a separate sub harness, because if you wanted to change gearbox, you don't have to worry about sending a harness back for adaptation or trying to cut up connectors or whatever like that. Just phone us up, tell us what gearbox you got, and we can supply you with the direct connection onto that. So again, unplug that, remove your J160, which is what this customer is running on his one. If you want to change over to an R154, W58, BMW, CD009, whatever it is, we can change that connector and give you the correct harness for your gearbox. Okay. Now, some of you may be asking, if I have a BMW or a CD009, there's no speed sensor on it. What do I do? Well, Toyota's been very, very nice, and with all of their models, basically, if you've had a look at them over the years, all of the auto versions from sort of 98 onwards actually got the speed from the ABS ECU. They didn't take it from the actual gearbox. The gearbox speed sensors on the auto just went straight to the ECU, and it was only for transmission control that they were using that. Now, what's really nice is they use the same ABS and TRC ECU, or VSC ECU in the case of an IS200, on the auto and the manuals. So basically, if you had a CD009 or a BMW gearbox, we would basically give you a plug which had only the reverse switch in, so you could connect that up. And when it comes to speedo, basically what we do is we take one wire from the ABS ECU in the driver's footwell there, and you can run it straight up to the cluster, and we've got instructions on how to do that depending on what year your particular model is. Okay, so again, don't stress about changing gearbox and going, oh, I haven't got a speed sensor. It's not a problem. You can get a speed signal unless you've ripped out the whole ABS system, in which case, well, then it's going to be a struggle. Okay. Right, so those are the three sections that pop out over there. Next up, you can see this little sort of creamy ivory colored plastic over here. That is what I call the under the inlet harness, sub harness, whatever you want to call it. But it goes through and it goes to the starter solenoid and it goes to the knock sensors. This is obviously the plug this is where it attaches to the actual engine harness. So this obviously unplugs if you want to remove the engine harness. What I'm going to do now is I'm going to show you what it looks like under there. So that's an overview from the top, you can see there, and now it goes to the starter solenoid, which is that little black connector down at the bottom there. It then goes to knock sensor 1, which is for bank 1, and then it goes to knock sensor 2, which is for bank 2. Okay, now obviously that's an existing harness that we've just taped up, so we can't put a label on there. So when you are fitting that sub harness back underneath the inlet manifold, because obviously the inlet manifold's got to come off to do that, please refer back to this video and you'll see that the two connectors are different colors. They also have different colors of wire going to them. So make sure you connect knock 1 to bank 1 and knock 2 to bank 2. Refer back to this video and you'll see exactly which one is which. Okay. Right, so that's that all done over there. And let's pop over to the other side. Okay, so the plastic runs across the back of the engine over here, and then we have a little section that pops out over here, which you'd miss if you weren't looking for it. So this is the other earthing point of the engine harness. Again, exactly the same as the other side. You're not going to have this bolt on a 3UZ, only this bolt, M6, 10mm socket, get that tightened up. Give it a clean with emery cloth before you tighten it up, okay? Next up, because it's a 3UZ and it's fully drive-by-wire, we've got our pedal harness. So again, everything is labeled for you guys. So again, that is your pedal harness. Again, we obviously make this on a separate sub-harness, so you can actually fit it inside the vehicle. And again, here it's going over to an IS220, 250, 350 accelerator pedal. This is one we can supply with you guys. We find it works the best from an electronic standpoint. I do appreciate these are not a straight bolt-in, and they usually require some sort of modification. But you are doing an engine swap, so a little modification is to be expected, okay? So the reason we don't use the ones like the SC430, which I think might be a straight bolt-in, if you watch my other videos, which are all linked down in the description, and I tell you why we do and don't use certain pedals, that explains that in great detail. Okay, so down at the bottom, I've got tons of videos there with lots of useful information. So have a gander at that when you got some time, and there is a bunch of useful information for you there. Okay, right, so that is the pedal, and then the harness carries on around to the right bank here. So the first breakout is obviously going to be injector 8 and coil 8. Super simple. Harness then carries on, and we have another breakout section over here, and that's going to be going to injector 6 and coil 6. But also, it's going to be breaking out to the ACIS system, or acoustic control induction system. Again, link down in the bottom. I did a very good video explaining the ACIS system, how it works. I pull a whole intake apart to show you all the internals and everything. That is obviously an acoustic control induction system, which is basically a variable intake runner length. Okay, right, so bearing in mind, you've got to get that harness to the starter and the knock sensors over there, so the inlet manifold is going to be off. Now is a perfect time to test this vacuum solenoid valve, which is actually underneath the inlet manifold. And I say that because it is underneath the inlet manifold. If you just lift it up, throw the harness on, throw this back on, plug it in, go to start it up, and you don't see this flap moving down like that, then you're going to have to pull the whole intake manifold off again to replace that vacuum solenoid valve, okay? And don't overlook it, because if this system is not working, you are losing a hell of a lot of low down torque, okay? A lot. Believe me, you will notice the difference if that's working and that's not working, okay? Right, so how do you test it? Well, relatively straightforward. If you look at your connector here, we've got a black wire there, solid black wire, that is 12 volts, and we've got a blue with a white tracer, that is ground, okay? If you put that over to the other side, basically there is a black wire and a white wire. So the black wire is 12 volts and the white wire is ground. Those vacuum solenoid valves are polarity sensitive, so you do need to connect it up correctly, but basically take a battery, a car battery, put two wires on, just touch it on here when you have the inlet manifold on the floor, and all you want to hear is it clicking. If you hear it clicking, that's great, no porries. Crack on, fill it all back again. Okay, if it looks terrible and the plastic's gone all brittle and you decide I want to replace it because these vacuum hoses might break at any time and it's going to cause me a lot of issues, then again, that is the best time to replace it while it's all off, okay? Then you have a little clip over here. I don't have the metal brackets that are on here, but this customer here, the clips did come with his harness, so assuming he has them on his engine, so he can clip the harness down onto those. If you guys want as well, you can just use P-clamps. You've seen some other videos. If I don't get these, I just tell people to put a P-clamp on and just bolt it onto there, because that's what Toyota do. Moving along, we then have our next breakout, and that is going to go to our cam sensor for our right bank. So exactly the same as the one on the left bank, measuring 3 lobes on the cam set, on the inlet cam, just to measure that the VVT-i advanced retard of the cam is correct. We're then also going to have injector 4 and coil 4, and then we have our other noise suppression capacitor, which again is going to bolt on here. If I remember correctly, there's a bracket that goes over here, and that's what that connects to over there. Again, I've removed everything from my engine because I don't even connect these for testing purposes. But yeah, so that goes on over there like that. Moving along, we then have our second clip, because you can see down here, we've got another mounting point on the fuel rail there. So again, this will just clip onto that clip over there, holding the harness in place. If you don't have these, just put a P-clamp on, does the same job, holds the harness in place where it needs to be. Right, moving to the front here, we then have a breakout, or a very big breakout section. So let's start with that. So first of all, we've got injector 2, we've got coil 2, we've got the oil control valve for the right bank, We then have our temperature sensor for the ECU. That's the 2-wire one. So we can get it to focus. Now, don't freak out. You guys are not going to have that sensor there. There's going to be like a little bolt, like a blanking bolt in there. So again, don't freak out when you see, oh, but my engine doesn't have that. I've added that in. That's not a standard feature. I've added it in because when we use aftermarket ECUs or when we do harnesses for not plug and play, I put an extra wire in so the customers can put their own temperature sensor in there, and I use that to test it. So again, don't freak out. I've added that in. Your engine will not look like that. You'll have that sensor there and you'll have a bolt in there, okay? Also, coolant temperature sensors are really, really cheap, and considering you're going all the trouble of getting this all fitted, I would probably advise to buy a new coolant temperature sensor. In the description below, I've got a long list of parts, from everything from the coolant temp sensors to the mass airflow sensors to the injector O-rings, the whole 9-yard timing belts, idler pulleys, whatever you want. It's a really, really long list down there. So if you need any parts for your engine, look down at the bottom there. I do make them specific for 3UZ, so you'll see down at the bottom there, it might say this is for an LS, that's for a GS430, etc., etc. I just made a universal one for 3UZ. But all down there so you can get your part numbers there, okay? Next up, we then have our wire going to our drive-by-wire motor. So that is actually the electronic motor, just a positive and a negative there, and that's controlling that. Then coming out over here, we then go to our mass airflow sensor, okay? These can be quite important because there are differences between like the GS430, the SC430, and the LS430. And then it gets broken down again if it's like a second generation GS430. I think the SC430 and the LS430, I think they carry the same one throughout from, in case of the LS from 2000 all the way to 2006. I think the SC is probably the same. But I think the SC and the GS have a 45-degree angled plug, as opposed to the LS, which has a flat plug, okay? So again, down below will be a part number for your specific one. If you're ever unsure of it, guys, and obviously you maybe have a different engine or something like that, the best thing you can always do is take your ECU part number, go into Toyota DIY, put the part number in, go to the air cleaner section, and in the air cleaner section, you'll see the mass airflow sensor, and it'll give you the correct part number for your vehicle, okay? Because I always say to people, match up the ECU with the MAF sensor because that's what you've got. I've seen plenty of instances where they may have a GS430 engine with a GS430 engine harness, but they've got an LS430 ECU, okay? So again, whatever your ECU is, pick the right mass airflow sensor for your ECU. If you have a different harness, it doesn't really matter because the wiring between a GS430 and an SC430 and LS430 are exactly the same. It's just that the actual sensors are different. So if you have an LS430 ECU, then get an LS430 mass airflow sensor. Don't use a GS431 or a SC431, okay? Right, so that's the mass airflow sensor. And then the last section that's gonna break down over here is gonna come down by the alternator. It's then gonna break out into 3 sections, one of which is your 3-pin alternator plug over there. Again, all standard. Then we have our low oil level sensor. Let's see if I can get this to focus. All right, that's gonna plug in over here, because remember, if you have a front sump, your oil level sensor is going to be here. On these mid sumps, your oil level sensor is on the other side. Sorry, back again, a bit of a technical glitch over there. So as I was saying, on the LS430 or the GS430 2005-2007 with the mid sump, the low oil level sensor is on the other side of the engine, hence why we build these brand new. So obviously if you've seen our GS430 engine harnesses or our SC430 engine harnesses, you'll see that the oil level sensor is not a new harness section that we build. It's actually the original one, and it just gets taped up like that, okay? Then lastly, if you can see at the back here, is our Lambda sensor, okay? So again, a little bracket holds it on over there, plugs in directly over there, and it goes along there. So I just want to clarify something which you can see hopefully on the videos, is that this side, the right bank, has a long wire for the Lambda sensor, and the other side has a short wire. Now there's a very important part to this. The actual Lambda sensor has different wiring. So you can't use the long Lambda sensor on the other side where it's supposed to be short, and you can't use the short one on this side. Not that you can use the short one anyway, because obviously it won't reach. But obviously I've had someone ask me before and go, oh, can't I just buy 2 of these long ones? And I don't have to like keep 2 other ones in stock basically, or in case I need to, they fail, I need to replace them. No, you have to have the long one on this side and you have to have the short one on the other side. Again, down in the description, I've got all of the part numbers for you guys, okay? I've also given you the Denso part number, so you can buy those, which are obviously much cheaper than Toyota, but obviously Denso are the one that manufacture them anyway, so there's no loss of quality there. Just make sure you get them from a reputable supplier and make sure that they are give you a quality Denso product that's actually made by Denso, not some cheap Chinese knockoff. Okay. Right, so as you can see, I've only gone through the Lambda sensors on the exhaust manifold. I haven't gone through the Lambda sensors on they would normally go after the catalytic converters. And that's because obviously as part of the remap of the ECU, we remove the secondary Lambda, so you don't have to run catalytic converters on this. Now, obviously it depends on your laws and your state and so on and so forth, where you have to from a legal standpoint of view. But from our electronic standpoint, you don't need to run secondary Lambda sensors. They're turned off in the ECU, so you'll never get a code for the dreaded like P0421, I think it is, for the secondary Lambda sensors. Completely removed, so you don't have to worry about them. Okay. Right, so now that is the actual engine harness, which again, hopefully is relatively straightforward, right? It just makes a U shape, goes around the engine, super nice and simple, nothing too complicated there. Okay. Right, so other things you need to take into consideration. Okay. Basically, what we're sending back to the customer here takes care of the starter motor because he's got his wire that's going all the way over there. It'll go directly to the battery, so that's absolutely fine. But things you're going to need to do that don't come with the engine harness and, well, never did come with the engine harness is going to be earths. So again, on an IS200, you have an earth cable that goes to the battery over there. It runs down underneath the battery, bolts to the chassis, goes down, and then it normally bolts to the block. And I'll see if I can get it here. But there it is over there, and that actually goes underneath the battery. So again, battery negative terminal, underneath bolts to the chassis and goes from there. So this might be a good time to lift up your battery, unbolt the plastic tray that goes underneath there. Look at that earthing point for the chassis, make sure it's nice and clean. If it's all rusted away, get it out, get a wire brush, clean it all off, bolt it back down again, spray it with some primer or something just so it doesn't rust again, and then put it all back together again. Right, so that is your main earth for your starter motor. So that goes to the block, because remember your starter motor is bolted directly to the block. These are these two bolts. There's one over there and one over there. So that's your starter motor, bolts to the block. So all you basically want to do is make sure you've got a decent cable going from the negative of the battery down chassis block, okay? The other earth that you might want to add in is if you look at your IS200 originally when you had the 1G-FE in, you saw that from the brake boost here, there was a rower pipe and there was a metal pipe that ran across the other side. And in the middle of that, there was an earthing point where it basically went to this side of the cylinder head on the 1G-FE. So just replicate that. You can use the M8 bolt over there, or you can use the M6 bolt over there. Just bolt that from there onto the firewall, and that's going to give you another earth, which is basically what Toyota do. And then the last one is down on that side over there, and it's a earth strap, if you want to call it that. So it's not like a PVC coat, or it's not a coated wire, it's just basically a flat braided cable that went from your chassis leg at the bottom there to one of your gearbox bolts. Again, I would advise to refit that one over there. That'll give you 3 earthing points. So your big one on the block for your starter motor. This one can go on the cylinder head, and that could be more sort of for the engine harness side. And then obviously one on the gearbox just gives you another one there for the block, which again, Toyotas do love earths. So don't feel bad about putting too many earths on. You just can't. Okay, so that is the grounding side. So you've got battery to block, cylinder head to firewall, gearbox bolt to chassis leg on the bottom there. That should cover you. You shouldn't have any issues running with that setup. If you want to add more, knock yourself out. Right, on the power side, as I've said, you've already got your starter motor main power cable that just bolts directly to the positive terminal of your battery over there. So that is no problem at all. So the only other thing you need to remember is this cable, which runs down and goes into the fuse box over there, okay? You must plug that in, okay? If you don't, none of your car's gonna get power, okay? So that is the main power that's powering the entire vehicle. So again, do not forget that. Normally this goes underneath and then that will actually go on top of that and you'll bolt that onto there. Remember, you have a different terminal, you'd only have one post. So this would go and then that would go on top of that and then you would bolt that down, all done and dusted, okay? There is another power that you need to add in. Obviously that is going from your alternator. So again, that's this one down over here. So as all UZ harnesses, the alternator wiring was never part of the main harness. Obviously they didn't want to run it in the engine harness and cause a lot of noise. So that's going to run underneath along the subframe, and then it's going to pop up and it's going to bolt in over here. Again, M6 stud, 10mm socket, get that bolted off. Now, in this case, the customer was actually very extensive in what they sent us. So he sent us the LS430 alternator harness wire, which is going to be long enough to reach from the alternator all the way underneath and up to the battery, or in this case, the fuse box. There is one downside though, and that is that this requires a right-angled connection over here. And there's actually a plastic cap that slides in there. That's what these clips are here for, okay? So in this case, what I've done is I've stripped those two down. I'm gonna put them in the box for him so he can actually take the IS200 alternator cable, which is gonna be too short, but he can cut off the end with the correct terminal that's gonna bolt into there, along with the black piece of plastic clip, and that'll go straight into there. And on the other side, it'll be the correct terminal. So use the 3UZ cable up to here, then he'll chop it, grab the IS200 cable, chop it, join it together, crimp it, heat shrink it, cover the harness, and then obviously plug that all in. So that goes from the alternator fuse box all the way down along the subframe, and it bolts directly up to your alternator. Okay. Right, so that is pretty much it for the electrical side, okay? So I've given you, the harness pretty much covers everything. It's straight plug and play into your ECU box as long as you haven't messed with the original connections. Earth, alternator, that's basically it. That's the only extra thing that you do have to add on, okay? One thing I'll have a quick say of is I do have a video down in the description below about how fussy these mass airflow sensors are, but I just want to reiterate to you guys, because some of you guys don't watch those videos, and specifically for the customers, I want to make sure that you are aware of it. You can see that I have a pipe in here. This is the PCV system. It goes from there into the inlet manifold over there. On the other side, because I needed to get to that section, you'll see I've got a pipe there, which goes to that side of the cam cover over there. Okay, now then, when you are fitting everything, if you're not going to use this original air box, okay, so you're going to lose this feed, which goes to over there. You need to make sure that if you are doing that, that you disconnect this as well, okay? So the reason that is, if you leave this open to atmosphere, this intake over here, it's going to receive uncalculated air, okay? So the reason this pipe is here is it's after the mass airflow sensor. So even though it's air that's coming in, it's going into the crankcase, okay? And it's being sucked out here on this side back into the inlet manifold, right? It's still calculated. If that goes to atmosphere, right? And this one goes to the inlet manifold, then you're introducing air into the inlet manifold, okay? That is uncalculated by the mass airflow sensor. And if you go watch my video, you can see what a difference it makes. Because basically I have the engine running and idling and I disconnect that pipe and you can actually hear it start to misfire. Put the pipe back on, runs as smooth as a baby's bottom, okay? So if you cannot run a pipe after the mass airflow sensor into the right cam cover, right bank cam cover there, then all you need to do is you need to remove this and let this go to atmosphere and let that go to atmosphere. But again, do be careful, obviously they do breathe. So again, this is going to be putting oil vapors everywhere. So you can either take it to your own catch can just to stop it from going all over your harness and all over your engine, or whatever you want to do. Some guys put little sort of air filters on there to stop the actual like oil vapor that's in the air coming out to actually get all over your harness and mess up your whole engine bay. But yeah, that is a very good one because I see a lot of people saying, oh, I've got this weird misfire, blah, blah, blah. And then I take a look at the photos and that's exactly what they've done. They've left this on there. They haven't connected that one up. And obviously there's your problem. Your air getting into your inlet manifold is not fully calculated by your mass airflow sensor. So your ECU says, this is how much air I should have. I'm going to put that much fuel in. And of course that's incorrect because it's getting extra air through that little thing over there. Okay. Right, so that's basically it. Hopefully that's nice and simple. Again, like I said, U-shape, a couple extra things like the earths and the alternator one that you need to add in and just make up. In this case, he's gonna have to make it up so you can have the correct connections on there and on the alternator itself. But again, super simple, nothing major at all. So what we're gonna do now is I'm gonna pop away. We're gonna come back and let's jump into the testing. See you in a sec. Right guys, so we're back now for the testing of the engine harness, and as per usual, it's made up of two sections, one with the ignition on and one with the engine running. First thing I'm going to do is I'm going to go through all the tests that we are going to carry out, and then we're going to jump into the testing with the ignition on. So let's go over to my sheet here so we can see exactly what's going on. So on the ignition on side, we're going to be testing ambient temperature. So basically all I'm looking for is the temperature to be displayed on the climate control unit over there. Because this is a 3UZ and it does have the ability, the outside temperature sensor is actually connected to the ECU, so therefore it will actually go up and down. It is actually sensing the outside temperature, so that will work 110%. Then we're going to pop over to the dash, and we're going to be looking for the check engine light, the charge light, and the oil pressure light, so making sure that those are working. Okay. After that, we're going to be looking at the gearbox harness, so we're going to do reverse and speedo. And I do apologize, I don't know if I actually went through this as part of the layout section, but anyway, there's the gearbox harness plugged in over there. It comes down to here to the reverse connector and to the speed sensor connector over there. Okay. Now for the reverse, all I'm basically going to do is use this wire to bridge the two terminals in that connector there, and the dash is going to go beep, beep, beep when it's reversing, which is standard IS200 stuff. But it's just to show me that the reverse circuit from there all the way to inside the vehicle is 100%. And obviously that means that when you put the gearbox in reverse, as long as the switch on your gearbox is working, your reverse lights will come on. In relation to the speed, we're going to be using our little device here. This is the same as the tacho corrector, but it does actually have an output facility. So I'm going to be using that to then feed the signals directly to the speed sensor connector. And we're going to see the speed on the dash go up as I do that. So if you've seen my other videos, you know exactly what that looks like, but you're about to see it when I go through the testing. Once we've done that, we're going to do the OBD2 test. What I basically mean is I'm making sure that it's connecting. So again, we are using GTS, okay? And obviously that is then going to communicate with the vehicle. So this is Toyota diagnostic system. You can actually hire it for like a day for €7, or like I think a year it's €460. You can do like 1 day, 7 days, I think, or like 30 days. Anyway, very useful if you have access to a laptop and you have yourself an OBD2 connector. This is a Tetrix Open Port 2, so I know that this setup works, and I've tested on all of my ECUs, so I know it should work on every single one. But this gives you basically dealer-level diagnostics, so it's really, really good. So if you're trying to find sort of cracked tech streams and you can't get them to work, very easy to do. If you guys want, I will do a video on how to find it, how to download it, how to get everything working. Just let me know if that is something that you are interested in. Right, so that's OBD2 test again. So we're going to be staying with the GTS, and we're going to be testing the fuel pump relay. We're going to test the AC clutch. We're going to make sure that the AC request signal and the brake switch are working. So again, these are all signals we're going to see on here. So you can see we've got AC signal, we've got stoplight switch, etc. So we're going to be seeing all of that information on there, and outputs, obviously we're going to be listening for relays clicking. Obviously gearbox selector wiring is not applicable. This is a manual setup. Then onto engine running, starter circuit. So again, basically what I'm testing is when I put the key in the ignition and I turn it to crank, the engine cranks over. That tells me all the wiring is correct on our side with the engine harness. ACIS, so with that one, it's just a visual inspection, but basically in the description below, I've got a really good in-depth video on the ACIS system, or acoustic control induction system as Toyota call it. Some people might call it variable intake runner length, but again, if you want to see exactly how it works, look at that video. It goes into great detail. I split the whole intake apart so you guys can see. All we're looking for in the test though is this must go from here to here, and it does that a few seconds after it starts. So you might catch it in the corner of the shot as it does that. Drive-by-wire test, well, that's super simple. We're just going to go with the pedal here and rev the engine. Remember, this is a full drive-by-wire system. There's absolutely no accelerator cable whatsoever. So it's not the hybrid system of the 3UZ-FE VVT-i and the IS200, where they had the sort of ETCSI badges all over them. Again, so as long as I rev the pedal, as long as I push the pedal down and the engine revs up, that's what I'm looking for. Then oil control valve test. Again, that's over to GTS. That's going to be able to then test both the oil control valves. That's the one on either bank at the front when I showed you in the layout section. What it's going to basically do is cause the engine to run a bit lumpy because it's going to advance and retard the cam. So all you're going to hear is smooth, lumpy. As I turn it off, smooth again, and then go to the next bank and we'll do exactly the same thing. Then what I'm going to do is I'm going to go round and I'm going to unplug each injector one by one so we can hear the cylinder misfiring as I do that. And that's going to show us that every single cylinder is firing exactly as it should. Obviously, we would get a diagnostic code if it wasn't firing. And you might actually see it's quite good if I obviously remove all of these. Sometimes I come back to GTS and I look at the diagnostic code, which is probably the last test on here. And it actually says that it picked up a misfire in each cylinder as I pulled the injectors out, which is fantastic, okay? Obviously, I've run the whole engine up to temperature and everything, so I know it doesn't misfire or have any codes for that. But yeah, just for the test for you guys. Then tacho. So we're going to go over to the gauge. We're going to look at the rev counter. Again, tacho, rev counter. Anyway, we're going to make sure that's working. And as I said in the layout section, when I went over that little box, the 3UZ and 1UZs give out a 4-cylinder signal, not a 6-cylinder signal. So we do have that little box, which looks exactly like that. That is obviously converting from a 4-cylinder to a 6-cylinder signal. Now, as I always say, I try my level best to hold the dash in a particular way and set it so that it looks correct, but you guys can feel free. It's really easy to adjust. All you basically got to do is pop off the lid, find this little potentiometer here, put a screwdriver in, and obviously turn it, and it will adjust your RPMs, okay? Right, so that's gonna be the tacho. For the coolant temperature, it's kind of like a double whammy. Basically, what I'm gonna do is before we get to the running test, I'm gonna let the engine heat up to about 40, 50 degrees. That's gonna get the needle off of the bottom there. And as we go through all the other tests, we're gonna come back and make sure that it has risen from its original starting position. Okay. And then last up, as I said, it is diagnostics. So I'm gonna show you how to do diagnostics and a couple of other little things as well as we go through, okay? Right, so without further ado, let's jump into the ignition on testing. So again, it is plug and play. So you guys should be able to, once you plugged everything in, come inside the vehicle, turn on the key, and away we go. Right, so let's pop over to the first test, which is the ambient temperature. And let's get out the light. There you go, 10 degrees. Fantastic. So that's absolutely brilliant. So we know that it is displaying the temperature. And again, that will go up and down as the temperature changes. Pop over to the dash here, and we're looking for the check engine light, the battery light or charge light, and the oil pressure light, okay? Now, obviously, you do have a low oil level sensor. I've removed the bulb because I do all non-VVT-i testing, which doesn't have it, etc. So again, obviously, your low oil level will work as well in this case. Please be aware that on the IS200, 300, or whatever, the TRC system is incompatible with the 3UZ, so traction control isn't going to work anymore. So that TRC bulb in the bottom here, you are going to have to remove that. So make sure you put that on your list of things to do. So again, otherwise it's just going to constantly flash in your face the whole time. And obviously be very annoying, okay? Right, so let's move over to reverse. So as I said, all I'm going to basically do is take my reverse plug over there. I'm going to grab the other side of the wire. And I'm just going to touch it over there. And there you go, you can hear that beep. As I pull it off, there you go. So again, just testing to make sure the reverse circuit is complete. And the reason I put the wire inside the terminal is obviously to make sure that the crimps on the connector are okay, that the crimps inside the ECU box are okay, nothing's loose or not connected there at all, okay? Right, let's move over to the speed sensor plug now, okay? Right, so as you know, this is my little device that I test if you've seen any of my other videos. And as you can see, as I put it in here, we get a little LED. I've got to put it in test mode first. But obviously this is a Hall effect style sensor. So when you have 3 wires on a sensor, it's usually a Hall effect style sensor, but that is not a rule, okay? Obviously make sure in your case, but on these Toyota gearboxes, R154, J160, W58, that's what they are. Now, obviously pin 1 is 12 volts and that comes directly from the gauge fuse. So if you ever wonder why your speed sensor doesn't work, you can also look at your gauge fuse and make sure that that is not blown. The middle one is the ground, and it also comes from the cluster to avoid ground loops. And number 3 is your signal. So that's coming from there all the way to the speed cluster over there. Okay, so basically all I want to do now is I want to put it into test mode. So let me do that now. Sorry, a bit difficult with the camera in your hand. All right, there you go. It's got a solid flashing light on there. That tells me that it's in test output mode. Right, and I'm going to get this all in the same shot here, and hopefully you can see, but as I provide a signal, speed sensor goes up. Fantastic. Okay. Right, so if you find that you're having issues when you install this and you're not getting speed on your dash, there are a couple of things you can check. Number 1, like I said, the gauge fuse inside the footwell over there. That's where the power comes from for that. But a telltale sign as well is if that fuse blows, it's the same one that supplies the reverse with 12 volts. So if you've got no reverse lights and your speedo doesn't work, check that fuse first. Right, if you check the fuse and everything's okay, the next thing to try and test, which is a little quick, easy, dirty test, is basically you can go underneath the vehicle, unbolt the speed sensor, pull it out, plug the connector in, get a mate or a helper to jump in the driver's seat, put the ignition on, because you need the ignition on for this to work, and then see if you can tape the drill to the gear at the end of the speedo and see if you can spin it. If you can spin it and your friend sees the speed, a helper sees the speed inside the vehicle, then you know that obviously that gear is not spinning inside the gearbox, and the problem lies inside the gearbox. If you still get no speed, then clearly something else has gone wrong in the system. So do check that you have plugged it in. Sounds silly, I know, but make sure it is plugged in, obviously. And from there, you can then give us a shout and we can help you troubleshoot from there. So where it goes from there to inside the ECU box, etc. And we can try and find where the fault is, okay? Right, So that's the reverse and the speedo. So OBD2 test. Let's quickly turn this back on again. It's going to re-communicate. I'm going to go to my testing section over there. Fantastic. So you can see we've got our intake air temperature at 16 degrees and we've got our coolant temperature at 33 degrees. So again, obviously I've tested all of this. I've let it go up to full operating temperature. I've let it cool down through the video section over here. Right, so first thing we're going to do is the fuel pump relay. So as I said, the fuel pump is controlled via the ECU. So I'm going to be able to turn it off and on with GTS. So as you'll see here, it says fuel pump relay and fuel pump. If you watch my fuel pump video, you'll know exactly why that is and why we don't use the fuel pump relay to test if the fuel pump is actually going to turn on. Right, so basically what I'm going to do is press the arrow there, and as I do, you're going to hear the fuel pump going on, so I'm going to keep quiet. There you go, hopefully you heard that. Usually does pick up on the microphone there, but that is the fuel pump. Again, it's being turned on via the ECU. I'm just using GTS to activate that output on the ECU. Next up is going to be AC clutch, so we'll stay on the output testing there. We're going to go over to AC magnetic clutch relay. We are then going to go, and again, we should be presented with the arrow. So I'm just going to do it now quickly. Now, the relay is in that box over there for the AC magnetic clutch. So I'm going to hold the camera there, and let's do it again. Fantastic, okay. Right, so that is AC magnetic clutch relay. So now we're going to go back and we're going to look at the data because we want to test the AC request and we want to test the brake switch. Right, so let's go back over to the testing one so we're not looking for ages through the data. There you go. Okay, so now we've got AC signal as currently being off. So here we go. We're just going to go and press the AC button. And here we're looking for AC signal is now on. Fantastic. And we're going to turn it off. And we're going to see AC signal is now off. Fantastic. Okay, so now we're going to test the brake switch, which I think I've already left on there. Okay, anyway, have a listen. You can hear the relay clicking away then as I give it 12 volts again. Right, so let's pop back over to GTS. And you can see here that my stoplight switch is now on. And let's go ahead and unplug it. Hear the relay click over there. And now my stoplight switch is off. Fantastic. So that's everything working on the ignition on test. Right, as I said, what I'm going to do now is I'm going to let the engine warm up a little bit. It's about 33 degrees. I'll let it get to about 40 to 50 degrees. As you can see, currently the coolant temperature is sitting on the needle there. Okay, I'm going to get it slightly off to the bottom there. So when we start up the engine, what we're looking for is it to rise as we do all the other tests. Okay, so for you it's a second. For me, a little bit of time, but we'll see you now. Right, guys, so now we're back. I've let the engine warm up for a little bit. It's about 56 degrees. I walked away for a second there, but still do what we need to. So you can see our coolant temperature is now off the needle. So happy with that. Obviously, it shows that it is working. But obviously, when we do the rest of the testing, we're going to see that it does actually go up. So we're making sure that it is actually working and it's actually reading the coolant temperature and it's going up as it does so. Quick recap of what we're going to be testing. Starter circuit, so turn the key and make sure it starts. ACIS, we're going to check that little valve closes over there. Drive-by-wire test, we're going to make sure the rev's up on the pedal. Oil control valve, we'll come back to the GTS over there. Injectors and coils, I'm just going to remove the injectors one by one, so you're going to hear it misfiring. Tacho, we're going to come back and make sure the tacho is working, probably give it a little rev as well, so you can see that's going up and down. Coolant temperature, that'll be by the end, so obviously we'll make sure that has risen from where it is now. So take note that it's sort of just by the second line, just above the second line there. And then we'll go through the diagnostics. Okay, right, so without further ado, let me get my ear defenders on, and 3, 2, 1. Okay, so that works perfectly. There you go. So you can see that that went down on its own, so that is fantastic news over there. Right, let's pop over to the drive-by-wire test. Okay, cool, so that's working. Right, oil control valve test, so let's pop over to GTS over here. We're going to test VVT-i control bank 1. start on this side over here as we're close. So let's go ahead and do number 8. Number 6. Let's do number 4. And number 2. Let's pop over to this side and we're going to do number 7. Number 3, and this one's always a pain, but number 1. Fantastic. Okay, so that is all of the injectors and coils working. So let's go over to the tacho. So you can see there it's about 1,000, and if I go onto the data list there, about 927, and then you can see it's dropped down slightly, so we'll give it a quick there you go. All right, coolant temperature, we can see it's definitely gone from 1 all the way to there, and we're about 68 degrees, so that works absolutely perfectly fine. Okay, so I'm going to quickly disconnect the fuel pump on here. So let's turn the ignition off. So I'm just disconnecting the fuel pump. I don't have to reconnect the computer and everything. Anyway, right, so if you wonder how long your engine will run without a fuel pump, there's your answer. Okay, so as you can see, the check engine light, the battery light, the oil light, that all went off. So that's fantastic. That's exactly what we're looking for over there. Okay, so last section, diagnostics. Right, so a few things you need to know. Number 1, unlike the IS200, you cannot bridge the 2 terminals inside the OBD2 port to get the check engine light to flash you the codes, okay? Unfortunately, the US and the European 3UZ models, it does not let you do that. Weirdly, on the Japanese ones, it does. If you've got a Celsius ECU, you can do the old trick of just bridging TE1 or TC and ground, and it'll actually flash the check engine light codes for you, so you can read it the old-fashioned way. Us in the US and Europe and the rest of the world, we don't get that luxury, so obviously we need to have a diagnostic machine in order to read codes, okay? Now, I don't have any experience in relation to things like those cheap Chinese Bluetooth OBD2 connectors and different modules. I've never used them before, so I cannot give you advice on that. Obviously, because of what I do, I prefer to have sort of dedicated diagnostic equipment. So again, I use GTS, which you can find at toyota-tech.eu. Like I said, you can pay €7 for a day's or 24 hours access. So again, if you want some dealer level diagnostics and you got yourself a laptop and you've got a cable, well, you can have that for €7 for the day for trying to diagnose an issue. Again, you can do up to like, I think a week and then 15 days or 30 days and then a whole year if you wanted to do that. So anybody out there that's doing a lot of work on Toyotas, might be useful to get that software activated. So if you have something like that, you can do exactly what I've done here. You can see all of the live data. You can see all of the diagnostic trouble codes, or DTC as they like to call it. So what we're going to do first of all is let's pop over to our DTC channel over here. We might get some codes for a detected misfire, and that's because obviously I've pulled all the injectors out. So let's see if we do get that. No, in this case we don't. So you can see we've got absolutely 0 diagnostic codes whatsoever. Okay, and that's important because, like I said, this is a manual version. Obviously, all 3UZs were auto. You can clearly see we have got no automatic gearbox. We've got no connections for it, and you can see we've got absolutely 0 diagnostic codes. Those have all been remapped out, and that is fantastic. We also have no codes for the secondary Lambda sensors. Okay, so again, those have been mapped out as well. So if you don't need to run CATs on your vehicle, then obviously you don't need to. Okay, but you'll also never get a check engine light if you don't run them. Okay, right. So that is the diagnostic section. So again, there's no way of guessing what your problem is. You do need to get some software and you do need to plug it in and you do need to see what the issue is. As you can clearly see from my testing, the check engine light goes off when the engine is running. So if everything is fine, if everything is okay, then obviously you will get no check engine light on your dash. If you do get a check engine light on your dash, then there is a problem with the sensor that you need to rectify, okay? So it's not a case of it's on because it's a swap, or no, it stays off. If you have a problem, it comes on, and you treat it exactly like you would your standard IS200. You get it plugged in and you can go from there. You can literally take this to a Toyota dealership if you wanted to, and they can plug it in exactly like I've done here. I've done nothing fancy. I'm using the standard OBD2 port that's in the engine in the driver's footwell here, and I'm just using a cable, plugging it in, opening up GTS, and I'm connecting to the vehicle absolutely fine. It picks up that it's an LS430, and obviously it can communicate with all the rest of the stuff in the vehicle like the ABS and so on and so forth. No dramas whatsoever. That's the beauty of these swaps, and why we do loads of them. They can be very, very complete and very comprehensive. Right, so as I said earlier, you can't bridge the terminals and get the check engine light to flash. But that does not mean bridging the two terminals is completely useless. You might be asking, what do I mean by bridging the two terminals? When you look at your OBD2 connector over here, you'll see that pin 4 and 5 are going to be grounds. So if you take a look there, you'll see that there's the two white with the black wires over there. And underneath that, you have a bunch of other wires over there, but more specifically, we're looking at the one that's directly underneath the earth wire there. So that's going to be 5 and 13, if I'm not mistaken. If you take a paperclip or something and you bridge these two sections over there, you're going to start seeing weird stuff happen, like lights, ABS light flashing on your dash and so on. It's putting the vehicle into diagnostic mode. Now, unfortunately, with the 3UZ, it's not going to flash the check engine light, but you can still read the codes from the ABS, if I'm not mistaken, because they will still work because it's an IS200, and you can read the codes the old-fashioned way about the ABS. But there is a more important thing that it does, or you might find useful, is when you put it into diagnostic mode, basically what's going to happen is going to lock the timing at 10 degrees, okay? Now, you might say, well, what use is that? Well, if you're having a bit of an issue with your engine running and you're not quite exactly sure what's going on, you can literally take a timing light, attach it to the wires on cylinder 1, okay? Now, not all timing lights do support that. I have a Sealy one, it does support that. I just put the clamp around the wires going to the coil, and I can check timing from there. If you take a look down here, you'll see you've got 0, 5, 10, and 15. Yours are probably going to be black, so you're not going to see them. I've obviously used Tipex or correction fluid to make it look really nice and visible. And on your crank pulley, if we're lucky, you don't always get lucky. There it is. Hopefully you can see it. There's that little dent in the crank pulley. I shouldn't say dent, it's like a little V channel over there. Again, I've painted that white so you can easily see it. But basically, I think I've got a couple of videos of checking like base timing when we do aftermarket ECU, so you can see exactly what's going on. But you can bridge those two terminals inside there, start the engine up, put your timing light on, and you can see if it is at 10 degrees. If it's not, maybe your timing belt slipped a tooth or whatever. So before you go pull all these covers off and you do check it, that's a nice, easy, quick check that you can do in the vehicle. Really straightforward, nothing complicated with that, and it'll help to diagnose whether or not timing is an issue on your engine, okay? Which brings me neatly onto my second point. Obviously, don't leave that wire or those terminals bridged when you're done. Take it out, because if you don't, you'll lock the timing at 10 degrees. And if you've ever seen an engine with a locked timing or 10 degrees, or driven in a vehicle with an engine with the timing locked at 10 degrees, you'll know how slow and how much power it does lack. Okay, so you'll know almost immediately if you've left the wire in. You'll feel it when you drive. Okay. Right, so that is the diagnostic section done. I think I've covered everything. So 1, you cannot do it by bridging the terminals. It won't flash the check engine light. Number 2, you do need to get some decent software or OBD2 scanner to be able to access it and look at the live data. Again, I've got no experience with the cheap Chinese version, so I'm about as much used to a chocolate teapot. If you're asking whether they work or not, I only use original stuff. But again, this is really easy to use, and I will make a video if you guys want. Just let me know in the comment section below. And obviously you can still bridge those terminals to check the timing, but please make sure if you do that, that you remove it at the end, okay? Right, so that's it. Another harness done. Everything's working 100%, which is great. So obviously we got to get this off now, get it to the customer so he can get it in his vehicle and get his car running, okay? If you guys have any questions, please feel free to comment down below. You can email us at info@phoenixenginemanagement.com, and you can find us on Facebook under Phoenix Engine Management and message us there, okay? When you guys do send queries via Facebook, I can't do it with emails, unfortunately, but if you do send us a query via Facebook, you will be automatically responded to with a link to a video that I have done to help out with the queries. It just goes into great detail about what information we need from you guys. Obviously, we're just a one-man band with a guy that helps out every now and again. So what I'm trying to do is to try and get as much information out of you as I can to help with the query, so we don't end up with a game of 20 questions going backwards and forwards trying to figure everything out. So if you do send us a query, please watch that video. If you send us via email, what I'll probably do is send that link to you via email if you send us an email, okay? Right, but thanks for watching, guys. We will see you again soon. Enjoy yourself. Happy New Year, obviously. And yeah, see you again soon. Bye-bye.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life, I never miss, that's fact, taking big swings, put your hand to the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean and I bring it to the mad light, ain't got time to kill, I got time to feel, I took the red pill.